This video is for Terry. He wanted to see how I'm build my rocket here. So this is a M2400 rocket motor, and I make a ring on a jigsaw that fits the outside of the diameter and a ring that fits the inside of the diameter, and then I glue them together, and I glue this in there, and the whole thrust is transmitted to the airframe here, and I mount the fins with a I glue a board. First I make the fins, and it has a structure in here for support. They're fairly strong. They will survive a flight, but as you can see here, if it lands on it, it won't support the weight. So, and then I repaired this one over here. It's not real pretty, but it'll fly. And I mount the fins. I bolt boards onto the body tube. It's probably only got a couple bolts in it, but it's glued. And so then I screw the it's 1/8 inch. I believe it's like a door skin. The board is only about that long, and I glue and screw the fin material to that board, and then I just kind of seal it to make it kind of, it's not going to hold anymore, but just for appearances, more or less. But it has a structure in here. I'm not sure how I made those ribs, but I pretty much make the fin first and then put it on and screw it on, and that works pretty well. On this where the motor goes, I think I have some L brackets in here. It's not really necessary because it would have to, it's glued in there for one thing, and it would have to shear this plywood. It doesn't have that much thrust to do that. But my motor mount, I make rings on a jigsaw, and this is a tight fit. So if I want to reuse this, I just cut the motor tube and remove this. It took a long time to make, so I'm not going to make one every time. But the thrust, it's on this nozzle fitting, so it's not going to go anywhere. And one benefit of having a motor stick out of the tube is that when it lands, it hits on this first, and not on the fins. But then when it tips over, it usually breaks the fins. Like you can see here, this broke here. But I can just put a little glue in there and clamp it, and it'll fly again. But in this area here, I have a short section of a real thin wall drain pipe just to pretty much center the top of my motor. It has a good clearance there, but it's only about so long, just to pretty much make for centering. So that part of the rocket's pretty simple. This is my my electronics bay area. This is my altimeter. It's a Perfect Flight straddle logger. It only cost about 60 bucks. They're real hard to get right now, but it's been a very good altimeter. I've probably gone through a dozen of them or so, because I've crashed 10 rockets, so I lose an altimeter every time I do that. But it's really a really very good altimeter, and I've recently gone to these quick connectors, and that's way better way to go than making the connections every time. And this is my ejection charge. I use 7 grams of black powder, and I have a video that shows the test of this. I tried smaller loads, and it's just inadequate to push that nose cone off. So I use 7 grams. I haven't had any problems. But I have a PVC, and then I put my ejection charge in there, screw this on, hook this up to my altimeter, and there's a bulkhead here that's bolted in there with the L brackets, and then I've sealed the electronics bay with epoxy, so it's confined to just this space. And I was really surprised I had to drill such large holes for the atmosphere sampling, but that's what it calculated out to be. So above the bulkhead I have 2 T's. They go up and in, and then a T that comes down. So it's kind of like a manifold there at the bottom off of the bulkhead. And it goes up each side of the airframe with a 1.25 inch PVC pipe. So the nose cone, I just formed a cone out of some real, like about 1/16 inch, of an inch thick, some kind of plastic like for a shower stall or something like that. And I just made a cone, and then I coated it with fiberglass. And down here I just mounted it on a piece of plywood, which is basically the base of my nose cone. And I made a piece of the tube here so it would fit inside there. It's not a very tight fit, but most of the nose cone is held on with these pistons. So, oops. It's a pretty tight. I usually grease these things up with silicone grease. So I have to leave that plug out of the bottom end there, or else it just pressurizes. So the nose cone comes down on a like an 8-foot parachute. It probably weighs like 20 pounds or something. But the way the recovery works is when the ejection charge goes off, the nose cone comes off and it pulls the bag with a 24-foot parachute out, and the bag is tied at the bottom with a quick release knot. So when that rope comes tight that's connected to the airframe, it pulls the parachute out of the bag. The two separate. Hopefully it's at some kind of an angle so that one's not right on top of the other, and I mean, it's very possible to have the two parachutes foul because they're both being deployed about the same time. So I haven't had any problems so far, but it's something that could happen. But that's it for the parachute. I also have a video camera here. I can, dang it. I mount my video camera in this quick release mount. I also have one that I can attach that points up towards the nose cone. I've only done that once, but it's kind of cool to see the parachute come out. And I just attached my altimeter with a screw through the body tube, through the hole. And that's pretty much it.